Well, good afternoon. It's section 1-9, Arithmetic Sequences. And why don't you go ahead and hit pause, and I'll give you a chance to copy down these two definitions. So go ahead and do that. All right, now we have arithmetic sequences, which says each term is found by adding the same number to the previous term. And again, arithmetic is dealing with adding. Geometric sequences is when each term is found by multiplying the same number to the previous term. Okay, so again, it's dealing with sequences, which another word for sequences is patterns, finding those patterns for a list of numbers. And here's the examples that we have. And I'll do the first one with you. It says describe the relationship between the terms in the arithmetic sequence. Then write the next three terms in the sequence. So we're going to first start out by going from 4 to 7 and finding that difference, which in this case is going to be 3. So we're going to add 3. And then from 7 to 10 is adding 3 again. And 10 to 13 is adding 3 again. So my next 3, so again, describing the relationship between the terms in the arithmetic sequence is simply adding 3. Okay? The next 3 answers then need to be the next 3 terms, which adding 3 on to 13 would be 16. 3 more added on would be 19. And 3 more onto that would be 22. Okay? So that's your answer to this problem. Why don't you go ahead and hit pause, and you'll see now we have some decimal points. So go ahead and do letter B. All right, so we need to find the relationship again, and going from 1 and 0/10 to 1 and 3/10. If you're not sure, again, find the difference. So 1.3 and 1.0, subtract, and you see you get 3/10. Okay, so going from here to there, we're adding a 3/10. See if that works again, and it does. Adding 3/10 and 3/10. So again, my answer to this is 3/10, and we are adding. Semicolon, we've got to add 3 more tenths onto this. So we get 2.5. And then 3 more tenths is 2.8. And 3 more tenths, again 2.8, and my 3/10. Just going to show you this to make sure you realize this. So we get 11. You're carrying the 1. Add that decimal point and 3. So we get our 3 and 1/10. So be very careful with that as you go through that process. Now let's look at the next problem, and I'm going to let you do the next one. It is geometric sequences, however. So remember that geometric means to multiply to find that pattern. So go ahead and find the relationship and the next 3 terms. Go ahead and hit pause and just do letter C. All right, we are working again multiplying from 10 to 20, and if you need to, you can always do the inverse and divide those to help find that, which is going to be multiplying by 2. Again, you could have found that by saying 20 divided by the previous term, which would give us 2. 20 divided by 10. So we're going to multiply the next one by 2, and it does. 20 times 2 does give me 40. And 40 times 2 does give me 80. So my first relationship is times 2. And then we're going to find the next 3. So then we're going to take 80 times 2, which is 160. And then we're going to multiply that by 2 and get 320. And multiply that by 2 to get my 640. Now go ahead and do letter D. So hit pause and solve. All right, you are going to now, again, we are multiplying. So times 4 times what give me 20, or again, we can do the inverse and say 20 divided by the previous term, which is 4, and 20 divided by 4 is 5. So 20 times 5, or 4 times 5 is 20. And then 20 times 5, does that equal 100? Yes, it does. And 100 times 5 gives me 500. So times 5 is my first relationship. And then we're going to take 500 times 5, which is 2,500. And then we're going to take the 2,500 times 5, so times 5, and we get 0, 0, 25, and then 10 plus 2 more is 12, so we get 12,500. And the next one, 12,500 times 5 is 0, 0, we get 25. And then 5 times 2 is 10, plus 2 more is 12. And then we get 5 times 1 is 5, plus 1 more is 6, to where we get 62,500. Okay, those are my next 3 terms. So be very, very careful in doing those. Now, one thing I do want to point out, if you were to, for example, have 4, 6, 9, 12, and so on, we're going to look for a pattern for this. And 4 becoming a 6 is plus 2, and 6 becoming a 9 would be plus 3, and 9 to that, actually I'm going to change this to a 13, plus 4. You can see the pattern is adding 1 to each one. So my next one would be plus 5, which would be 18, and so on. This is not an example of arithmetic or geometric sequences. Okay, it is adding, okay, for arithmetic. However, it is not the same term. Okay, when we look at our definition to this, okay, it has to be the same number to the previous term. So therefore, this is a pattern, it is a sequence, but it is not arithmetic. Just because you're adding, it has to be the same number to each. All right, so I just want to make sure you are clear on that. It's pretty easy assignment, I think you'll find today, and hopefully have a lot of success with it. So have a great night, and we will see you tomorrow.